everybody. Happy Thursday. Welcome to episode 4 of Lowry at Home. I'm your host, naturalist Kirk. On today's episode, we're trying something a little bit new, a new segment called Do Try This at Home, where you get to do a bit of a science experiment and learn a bit about something sciencey that you can try at home. This is going to be something that is hosted by, me. So let's head to the kitchen. So here we are in the kitchen, and that's where we're going to do our experiment today. You are going to need an ice cube, a little bowl of water, and a piece of string or yarn. And if I put this ice cube in there, there's really no way to pick up that ice cube with the string, and that's our challenge, to try to somehow pick up the ice cube with the string. And what you find is that you really can't do it. But I'm going to show you a little trick. If you line that string right there across the ice cube, and then add a magic ingredient, we're going to add some salt. So I'm going to take a pinch of salt, and I'm going to sprinkle it on top of the ice there, right where that yarn is going. And now we're going to wait a second. And what's happening right now is the salt is melting our ice a little bit, but it can't really melt that ice completely. It's just going to melt that top layer a little bit, and the mass of that ice is so much that it's going to be cold enough to refreeze that bit of water that just melted from that ice, or from the salt. So here we go. Let's try it. We're going to pull on our yarn. Oh my gosh! We just picked up an ice cube with a piece of yarn. Now, I explained the basic idea of what was going on there, that the salt started to melt the ice a bit, and then it kind of refroze with that the coldness of that ice on there. But there's really more to it than that. So for the older folks in the audience who want more explanation of what's going on here, let's really think about this for a second. You know, we put salt on our roads here in Minnesota in the winter, and we do that to melt the ice. But how does it happen? And I was sort of racking my brain thinking, how do I explain this experiment to people at home with just stuff that I have around the house? And here's what I came up with. I'll tell you what I got in my pocket. I've got batteries. Okay, let's use these batteries to try to explain what's happening. If each one of these is an atom of water, okay, or not atom of water, a molecule of water. Water is made out of hydrogen and oxygen. So each one of these is a little molecule made out of 2 parts of hydrogen and 1 part oxygen. When it's water, they're all just sort of moving around however they want, slipping and sliding, right? As the temperature goes down and gets closer and closer to 0 centigrade or 32 Fahrenheit, they're gonna sort of start to organize themselves more and more and more. So I'm gonna take the positive side and put it by the negative side here, positive and the negative, like that, okay? And so what's happened is, as they've slowed down, they have less energy, and they're gonna try to line up. So some of the oxygen on the ends is gonna bind to some of the hydrogen on the other end. It's a little more complex than this, I know, but they're basically gonna form a crystal. And ice is a crystal. And so this is going to be like a water crystal. What happens when you invite salt to the party, though, is everything goes crazy. Because salt, and we say salt, but really salt is sodium chloride. It's sodium and chlorine mixed together. And both of those love to bond to other stuff on an atomic level there. And when it comes to the party, these little weak bonds here that the ice is trying to form, or the water is trying to form with other molecules of water, sodium's like, you know what? I want in on that party. Let's see what happens. When it comes right to these spots right here, and it goes, no, 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 okay? And it breaks all those bonds up. And so it can't form that crystal structure anymore. And what happens? All of a sudden we've got liquid water again and not ice. And so this is basically what salt does on the roads. It comes in, and it bonds to all that water as well, and keeps it from kind of sticking to itself and forming a crystal, and that's why we don't get that. Now, it doesn't work perfectly. We use the Fahrenheit system here, so I'll say when it gets down to about 4 degrees below 0, that doesn't work anymore, and the ice overcomes that, and it bonds to itself anyways. So that's when we have to put salt and stuff on our roads in the winter. But this is a cool little experiment you can do at home. You can try it out. Get some yarn, get some ice and get some salt, and you can invite salt to your ice party and have it break up all those bonds. And then when that gets cold enough, it refreezes onto that yarn, and that's how salt can be used to melt ice and then have it refreeze, and we can pick it up with a piece of yarn. Thanks for watching. Hey, thanks, me. You did a great job, I think. So that's it for today's episode. I want to thank everybody who's been sending in their photos for us to use during our pre-show countdown. It's been really fun to see those. Please keep sending those in. The address is right down at the bottom of the screen there in our end card. But thanks so much for stopping by. We'll see you tomorrow. Tomorrow we've got another live animal program from naturalist Lauren. It's going to be a lot of fun. Please stop on by, and thanks for coming today. There's the dog.